Hello YouTube, this is Frank, and this is December the 2nd, 2024, and this is my 86th video and my 7th Libre Computer video, 1 out of 8. And today, in this series, I'm looking at the Libre Computer Tritium, and I want to make an NTP time server with a GPS module. And so this is the introductory video. So we want to go through, set up the Tritium, install GPSD, install NTP, some data analysis videos, and look at the some of the data analysis that comes with NTP, and then set up a time server. I'm going to move my board down. Let me show you what I got. Let's see. Frank, let's see. Disclosure, I have no financial, employment, personal, or family relationship with any brand or product. I purchased the products that appear in my videos with my money. I'm retired. I just butter around with computers, networking, and software. AI was not used in this video. There are no AI-generated images or text in my videos. And the videos in this series introduction, this is the first of 8. Summary, if you don't want to watch the rest of the video, this is what this video is about. The whole series is make an NTP time server using a Libre Computer Tritium, just a commodity USB GPS receiver with a magnetic base. I like the magnetic base, and I'm using Debian 12 bookworm from the Libre Computer website. If you just plug in those receivers and do no calibration at all, I get about a 60 milliseconds from the universal time. Now, back in 2019, when I set up my, another network with the Raspberry Pi Zero and a GPS receiver, that's what I did. I just plugged in the USB dongle, installed NTP, and just let it serve time on that network. Now, you can get down to about 10 milliseconds, plus or minus 10 milliseconds from universal time if you calibrate that NTP. That's what a millisecond is. It's a thousandth of a second. And I put my GPS receivers on the inside windowsill. They're not even outside in the open, in open space. Now, this video is not, at this time, I'm only interested in Debian Linux. The Debian maintainer has most everything prepared for GPS and NTP in their server distribution, and I'm not interested at this time in other Linux distributions or in the BSDs, free, open, or net BSD. This video is not a video series on how to make a pulse per second Stratum 1 time server. Those are microsecond accuracy. That's 1/1,000,000th of a second right there. I'm not interested in that. I don't have any devices that require microsecond accuracy, and I do not have the switches and routers needed for IEEE. You got to buy the hardware for that to really take advantage of it. Yeah, all of my devices, they're general purpose and consumer grade. And there are tens of millions of computers that are synced at the general purpose NTP level. Let me show you what I'm talking about. I've got a graph down here. I was collecting data. Here we go. That's what I'm talking about. This is that GPS dongle, and that's compared with the servers on the internet, and they're kind of, plus or minus a few milliseconds, and that's kind of what you see on the with NTP on the internet. And if you don't, now sometimes I just don't even calibrate mine, and I'll just plug it in and go, and you can get about within 60 milliseconds of universal time. That's not bad if you. I'm just not. I really don't have a need for great accuracy, but you can. Let me show you this right here. Now you can. There's the that's the median line right there. You can adjust it, calibrate it, and move this up here so that it kind of oscillates there around the zero, and you can get plus or minus 10 milliseconds if you want to do that. And that's not very hard to do. That's very easy. But I just wanted to bring that to your attention. Let me get back to my notes here. Into the summary. Now there's a number of options if you've got an isolated network. You don't have to use the original network time protocol, the NTP software, Crony from Red Hat, and you don't even have to go with the GPS dongle. You can go with a real-time clock. In my old job, I synchronized about 40 isolated devices every month for 15 years. And the best as I can remember, the clocks were off about 5 to 30 seconds when I did those monthly clock checks. And the good real-time clocks were off about 5 seconds per month. And the not so good ones were off about 30 seconds per month. Let me show you that Wikipedia quartz clock page right there. Let me show you kind of what I'm talking about. Quartz clocks. Let me go down here to the accuracy. Go past, there it is. So they're saying in the Wikipedia page, it's a typical clock gains or loses about 15 seconds per 30 days. Now, that's kind of in the range that I was seeing with all those devices that I was setting the clocks for the 15 years. Adafruit sells some real-time clocks that you can put on a Raspberry Pi computer. This is not a Raspberry Pi here, but it goes on just slides over the pins, the little pins on your general purpose I/O pins right here. And you don't have to do any soldering or anything. Just slip that thing on there. And they've got two. They've got a precise one, and then like the 30-second per month clock right there. Battery not included. Now I have not used those real-time clocks, those Adafruit real-time clocks in my projects, and I may add one to my project list. It's kind of interesting to work with. Now the GPS receivers that I'm talking about, they're in the $15 to $20 range, and there's no pulse per second with these receivers. and they're not designed for microsecond timekeeping. Now, you can use them for millisecond timekeeping on the servers. Now, I just purchased whichever UPS receivers on the or GPS receivers on the Amazon overall pick with the magnetic base, and I don't know enough about them to really to recommend anyone. And I've got one right here. This was the one that I recently bought to replace my the one that stopped working. And on the back, there's the applications, and the applications. Let's see if it will. They're on navigation, so they're really not. I mean, even on the package, it tells you that they're this for navigation and they're not designed for timekeeping. But I mean, if millisecond timekeeping is okay, I think that's what I use. That's what I'm saying. Now there's a National Institutes of the National get over there. Well, National Institute of Standards and Technology. Now they do have a paper on some of the NTP timekeeping here for the stock exchange. Let me get over here to. They have a table I wanted to show you right here. I was reading this paper and I was looking at this table for the stock market synchronization standards requirements, and right now, like the requirements now are computer clocks synchronized to 50 milliseconds. So if I were to have this $20 GPS receiver, I could just about meet that requirement. But anyway, they do have some other requirements. There's 1 second, 1 millisecond, and 50 milliseconds. So I just wanted to bring that to your attention. Now down the paper a little bit further. Let's see. I think there's the network time protocol, NTP. That's what I'm talking about. Developed by David Mills, and now the other protocol is the NTP. It's included with many operating systems. It's been around, I think, since the 1980s. There's another protocol. Now, if you wanted to have that microsecond accuracy in your network, that's an IEEE standard right there. That precise precision time protocol. And it started out in industrial measurement and control, and now it's used in the financial markets for their precise time. And I wanted to bring it. So down here, precision time protocol. It's usually implemented in hardware, and so you got to have the routers and switches that implement that IEEE standard in your hardware. Now, I've just got consumer quality routers and switches, so it's even if I had that precise microsecond time, I really don't think it can be useful to me. NTP is generally implemented in software, and precision time, it's mostly on their local area networks. NTP, it's just widely used on the internet. But I just wanted to bring that to your attention. That's that paper. Let me get back over here. Yes, most servers and computers. Now remember that table I was showing you? Let me show you this right here. Let me bring this to your attention. Oops. The network time protocol. That's what I'm talking about. There's a picture of David Mills right there. He invented this. Now let me bring this to your attention. There's several different methods you can get to set the clocks to universal time. Oops, let me get back. GPS, that's what I'm talking about right here. And if we get down just a little bit further, Windows time, right here, Windows time. It's can be configured for 1 second, 50 milliseconds, or 1 millisecond. And I wanted to bring this to your attention. Now this is in the Microsoft web pages too. If you want to go to their documents. Here's that paper right here. Let me show you that table again. I was reading this paper and I saw this table. Now this is for the stock market requirements. And so there's that 1 second, 50 milliseconds, and 1 millisecond. That was just, I don't know why Microsoft chose that, but it's just noticeable that you see that 1 second, 50 milliseconds, and 1 millisecond. Let me get back to where I was. Oh yeah, let me show you about let me just show you what I'm talking about here with the National Institute of Standards there. Now I just got just a consumer PC right here that I'm using all the time. Let me refresh the page here, and it'll show us what my clock. See, my clock is off. My clock is off 3.41 seconds. So it's not. I mean, these are consumer applications, and I really don't. I mean, I don't even. I really don't have anything here at the house that needs precision. I don't. Yeah. But anyway, when Hurricane Helene came through in September 2024, it crashed that time server that I had running since 2019, and I was using a Raspberry Pi Zero W and just a commodity USB receiver, so I had to build a new time server, and that was in October. And I used a computer Renegade, Libre Computer Renegade for that. Now the instructions, they're scattered across the internet, and they're kind of stale. So I wanted to make this video to kind of show you how to make a time server with a Libre Computer Tritium single board computer. on my isolated network. Let me show you what I'm going to move this down just a little bit. Let me show you what I'm talking about right here. This is that Raspberry Pi Zero that crashed, and you only have one USB 2.0 port right there. And what they, I think I've got here's my Tritium right here. So right here I got, there's 4 USB ports here. So when I was wanting to make my new server, I got 4 ports right there instead of 1. And I got an Ethernet port right here too. Oh, and there's the full size HDMI connector right here. And I think I've got this was that UPS, the USB GPS dongle that crashed. It doesn't work at all anymore, but I did want to show you what one of these looks like. It looks similar to a mouse. And I just put this on my windowsill. I don't even put it outside. I put it on a windowsill. Let's see here. Now I've not tried the Tritium with the Wi-Fi dongle. I'm not sure if there's going to be any contention issues with that USB controller. So I did show you, there's the Tritium. This is the box right here. The box it came with. GPS receiver. I just get whatever is on the Amazon list, and I'll be playing around with just a consumer router, and that's what this video series is about. Let me show you the Libre Computer webpage while I'm here. They've got a number of products. That's the Tritium. I think pretty much any of these Libre Computer products would work as a time server. There's that Renegade. Back in October, I had one around, and I just went ahead and used that as my time server on that isolated network. And I've got some of these Tritiums here to play with. So and setting up, it should be pretty similar to, if I set up one, it's pretty similar to all the others. There's those GPS modules. They usually don't come with software or manuals, and the user has to decide, has to install or write their own software, or you can use commercial software. Let me get back to my notes. That's the end of this video, and the next one will be how to set up a Tritium computer with operating system. So thank you.